Dr. Rashid, should I start? I hope I'm audible to all of you. Good afternoon and a very warm welcome to all the participants and our speakers for today's session. This is Mukhtar Mahmood and I'm going to moderate today's session about the cost reduction opportunities in manufacturing process that includes eliminating the inherent losses of the compressed air and opportunities of saving energy and money. So before we proceed to our today's discussion, we're going to brief you a bit about our today's webinar that's in joint collaboration with AIIA and VPInstruments. AIIA is basically, it trains, it makes people realize their true potential, and it is the only institute in Pakistan that is addressing the compressed air engineering and manufacturing skills. It provides industrial air engineering, factory automation, and production engineering. The services of AIIA particularly include training of the industry professionals, training of the fresh grads, customized trainings, and opportunities as the resource person as well. So we are now going to start with today's session about the topic that revolves around the compressed air. Compressed air, it's basically a very important utility that is often one of the costliest energy consumers in any facility. So yet most of the compressed air systems operators, they have little knowledge of the compressed air system performance, its efficiency, and the energy that is being wasted as well. So roughly, it's just like 15% of the total input energy, which is utilized out of the compressed air systems. The remaining 85% actually gets wasted in the form of heat losses, leakages, and etc., making it one of the most inefficient utilities in the country. So different parameters can bring huge opportunities for the energy saving options, and it can lower the production cost as well. So Nitin, basically the representative of the VP Instruments. We have with us Dr. Arshad and Mustafa Ahmed from Pakistan. Nitin Sumaro is basically the sales manager Asia Pacific at VP Instruments. He's working on the compressed air monitoring projects for more than 10 years now. His specialities are around the account management and the business development for the Asia Pacific region, and he contributes to the sales strategy and marketing activities. Also, he's developing and providing on site training and seminars on the energy management and reducing the carbon footprints. We have with us very renowned Dr. Ashad. He's also the recipient of Satara Imtiaz and Pride of Performance from Government of Pakistan. He has completed his PhD from United States of America and has served as the Executive Director of Higher Education Commission, ATC, and the Vice Chancellor of National Textile University, Faisalabad, and Dean NUST Islamabad and Pakistan Air Force. We have with us Mr. Mustafa Ahmed. He is basically the team lead of Air Audit Private Limited and has an extensive experience of 8 years in the compressed air auditing and system optimization, and has an MBA in the industrial management. So welcome on board all the panelists. It's lovely to have you here.
Thank you.
Because we are very short on time today, so probably I will start with the questions, because the questions are there, and then we have a huge participation from our guests as well. So if anyone has any sort of questions, I would recommend that they can share it on the chat box that is available, and we are going to ask these questions from our panelists at the end of the presentation that will be delivered by our these speakers. So Nathan, how are you? How's the weather in Netherlands, and how is the corona activities going over?
It's yeah, the weather is quite nice actually today. It's 30 degrees. It doesn't happen too often here, so that's nice. In terms of the
Great.
corona, it's getting a little bit better, but still our business has been affected. But nevertheless, we see in such difficult times that people, they need to save money nowadays on their production. So actually during a crisis situations, we always see a increase of sales because of companies wanting to save energy and save a lot of cost actually. So yeah.
I hope that the conditions they do get better. They are slightly improving in Pakistan as well. So Nathan, I will first of all start with a very basic question: that why compressed air is important in manufacturing, and what kind of losses are there actually?
Yeah, I think that's a good question to start with. So yeah, to answer your question, I would like to share my screen with you guys and yeah,
Sure.
show you um, some things about compressed air system. So um, I hope all you guys can see my screen now.
Yes, we can.
Yes, we can.
So yeah, that's great. So why compressed air systems? First of all, it's the third or fourth utility within most production companies, besides water or steam or electricity. It's 8 to 10 times the cost of electricity, and it's most often 10 to 30% of the total electricity bill of an average industrial company. Uh, Looking at textile companies, it's actually covering 70% of the electricity bill. So it's a very huge amount in textile industry. As you all will know, is textiles is one of the largest industrial sectors of Pakistan, and compressed air is one of the most vital and energy intensive utility of these textile industries. And then especially in weaving processes and spinning plants. Um, the reason why we focus on compressed air is because it's misunderstood by most users and engineers. Most users and engineers, they think that uh, air is for free, but that's true. Air is for free, but compressed air is very expensive. So it holds a very high potential for energy savings, and it's a vital utility for the production machinery and processes. Without compressed air, basically 90% of the of the industrial sector can just close their doors. So looking at the cost of compressed air, the cost is 8 to 10 times more than electricity because there are a lot of wastes in compressed air system. So as you can see, you put in 100% electricity, and over the biggest chunk is being lost in heat, and then the rest of the air which is being produced, only 50% is being used effectively, and the other 50% is wasted. So when you go deep dive into a compressed air energy cost over 10 years, you can actually see that 75% of the total cost of ownership to run a compressed air system is energy cost, and only 12 to 13% is equipment cost and maintenance cost. So if you would look at saving money on compressed air systems, uh, I would definitely take a closer look at the energy cost and not in the initial investment that you have to make for the equipment, or cutting budget on maintenance, because that's only a very small part of the compressed air system cost. So looking at the losses, here, you can see that most of the losses are in leaks, and then the rest is in artificial demand and inappropriate use. Um, so basically, we are going to focus on that as well. So hopefully that answers your question, your first question.
Vaktavar, your mic is
Yes.
off.
So yeah. So in continuation, the first question: how to reduce the losses in the compressed air systems?
Yeah, that's also, I think, a very good question. And if you yeah, take a closer look at how you can save, first of all, you can look into overall system design, meaning you can change the piping to have less friction, so there is less pressure drop. However, the total cost of changing your piping is very high, so the return on investment is very long. You can also look at recovering waste heat, or implementing adjustable speed drives, or look at all other kinds of measures. However, the biggest and easiest way to save energy on a compressed air system is reducing air leaks and optimizing the supply side. And you can do this with permanent monitoring, because if you look at this graph, you can see the energy consumption is plotted over time. So let's say, for example, we implement a compressed air system in January. You will see that over time the cost will increase. So if you do, for example, if you do no audit, the cost will keep increasing. If you do a periodical audit, the cost will decrease after the audit, of course, because you do an audit and you take corrective measures. But after a while, the cost will go up again. And then here, for example, you need to do another audit, and then it will increase again. So if you implement a permanent monitoring system, you can keep track of your efficiency and you can take immediate action. So why do you want to permanent monitor? Is because you want to track the efficiency and maintain your savings and allocate the cost, because you want to save time, and also because you want to be on top of savings. So I think to answer your question in a short way is permanent monitoring to um, analyze the data and find the losses would be the best way of saving energy on a compressed air system.
All right. So, in continuation to this, what are the effective ways of the compressed air monitoring and its relationship to grid energy management?
So if you want to effectively monitor a compressed air system, then you need to know what is a monitoring system. So when you look at this slide, you can see that a monitoring system consists of sensors, and all sensors being connected to a centralized system for data analysis. So in this example, you can see we added kilowatt meters, flow meters for wet air, dew point sensors, and flow meters for dry air to measure the individual uh, areas. So where do you need to start when you want to do effective permanent monitoring on your compressed air system? Is first of all, you need to start doing efficiency monitoring of your compressors. So efficiency monitoring is done by connecting power meters and connecting flow meters to the output of the compressors. So this will give you the efficiency per compressor. Um, and then you can keep track of the efficiency and see if it's still within your um, preferred uh, efficiency rate. If not, you can take immediate action. Secondly, you need to install flow meters in the header or in the different branches for leakage management and cost allocation. And further downstream, if you want to take it even a step further, you can go to point of use measurement. So measuring the individual machines, um, which will result in a better maintenance management and also a better pressure loss management. So hopefully this will give you an overview.
Yeah.
So what is
So,
the value?
yeah,
First,
go
I
on.
need to finish your question. So what is the value of permanent monitoring then as a conclusion? First of all, you will have a constant eye on your consumption because you see it in your monitoring system constantly. You can detect leakages and waste on time and not after 6 months or after 1 year, where your leak has been leaking already for a long time and you've been losing a lot of money. You can benchmark multiple machines or production sites. If you, for example, you have multiple machines and you're measuring all the individual machines, you can see the differences between each other, and you can also see which one is more effective than the other one. You can optimize service interval and maintenance, meaning you can, for example, if you install sensors before and after a dryer or before and after filters, you can see immediately if the pressure loss is too high, so you need to change the filters or you need to change the desiccant. Um, so permanent monitoring is not only for saving energy, it's also for optimizing your maintenance management. Also allocating cost, meaning if you install sensors to each individual area in your plant, you know exactly the amount of air being consumed in that area. So you also know how much each area is costing you. If you implemented a permanent monitoring system, you can also understand the impact of new production equipment. For example, if you have a permanent monitoring system in place and you add a new compressor, you can see immediately what the effect is of your new compressor. Is your total system running more efficiently or less efficiently? If you add a dryer or if you add a new machine, if you increase your production or if you decrease your production, you can immediately see if your compressed air system is still running efficiently. And last but not least, troubleshooting problems and trending your compressed air system. So hopefully that
All right.
answers your question.
Yes, it did. Nathan, how is the cost of monitoring and its return on investment justified in the developing countries?
Yeah, that's a good question. I want to look at the return on investment of a compressed air system. Um, so here you can see an example of 5 compressors, where 3 compressors are running 24/7 and 2 compressors are running 50% of the time. The power of the compressors is all 200 kilowatt. So you can see the total kilowatt hours and the total cost in Pakistan rupees. I took an average of 1 kilowatt is 12 rupees. And you can see that the total cost per year for all your 5 compressors to run, it's 84 million rupees. A fact is that you can save 10 to 40%. So this is a industrial fact. In every factory, you can save minimum 10% up to 40% of the compressed air cost. So if you would take a minimum of 10% for your initial budget for your phase one, you can implement flow meters and monitoring with a budget of 8.5 million rupees. And then your return on investment, probably it will be less than 1 year, but it will be maximum 1 year. We typically see return on investments of 3 months, 4 months, 5 months even. But if you take 10% of your yearly cost to run your compressors and you invest that in monitoring and measurement equipment, chances are very high that you will have a return on investment of 1 year, and then each year after that you will keep saving energy. So when you look at so coming back then to your question, when you look at developing countries where the labor cost is low, it's actually not about the labor cost, it's about the cost for electricity. And as you can see, the cost for electricity is quite high in Pakistan. It's 12 rupees for 1 kilowatt hour. So this results in a very high cost to run your compressors. So it can run much more efficiently by investing only 10% of the yearly cost. So hopefully that answers your question on the
Yes.
investment.
So, Nathan, can you please share a real life case study relevant to the topic that we are discussing at the moment?
Yes, we have. We have a lot of case studies. I can show you two now. Um, so, for example, in a glass factory, Owens and Illinois, we implemented VP Vision with 20 flow meters throughout the supply and demand side, meaning we installed flow meters before the dryers and after the dryers and tank, and we combined it with their existing energy management system. So, what were the saving measures they could take after installing our system? First of all, they found out that there were leakages in machines. So this was already a huge saving. Uh, they could optimize their oven cooling, and they found out they had problems with their compressor inlet filters. So all the measurement equipment showed them that they had many problems in their factory. They justified them, and the return on investment was 1 year with a total saving of 200k euro per year. We also have another project which we can share is a steel factory. They also implemented VP Vision with flow meters, kilowatt sensors, pressure sensors in 6 compressor rooms. The saving measures they could take were changed to blower air instead of open blows from compressed air. So after measuring, they could find out that they actually easily could use blowers instead of compressors. So this was already a huge energy saving measure. And they could shut off old sections because they had old sections where the valves were continuously open, but these old sections were only running a very small part of the time. So after measuring these old sections, we could determine that there was just too much leakages in this old section, and it was the cost of changing all the leakages and changing the piping is very high. So what they've decided to do is just shut off the old sections when they are not running, and the return on investment was 6 months with a total energy saving of 300k US dollar per year. So these are two cases where we have seen very high energy saving potential.
All right. So now, Nitin, talking about the landscape of Pakistan, is there any industry in Pakistan that's currently using the compressed air monitoring systems, and what has been their feedback so far?
Yes, we have actually. I would like to ask, yeah, Mustafa to answer this question because he was involved with this project
Sure.
very closely.
Absolutely. Thank you, Nathan. In Pakistan, we have been successfully implemented this whole VP instruments monitoring system, VP vision system with 4 flow meters and energy meters and pressure sensors and dew point sensors in one of the biggest towel manufacturers of Pakistan, naming Feroz 1888 Mills. They're the biggest towel manufacturers in Pakistan, and we've implemented VP Vision system on one of their plants, and which has benefited them in a significant way. In one of the biggest improvements they've made is they've increased the efficiency of their compressors by monitoring its output, and after installing wet flow meters on the immediate output of their compressors, they actually got to know what compressors is actually producing, and they were able to improve it by improving the ambient conditions of the compressor room. Also, a great amount of pressure reduction was achieved through monitoring the pressure delta of each dryer they have. They had pressure sensors on in and out of a dryer, which was being monitored through VP Vision, and they detected a great delta reading on each compressor, which they fixed. So it was a continuous saving to reduce the pressure to 1 bar after improving their pressure flow through the dryers. Also, leakages in their all departments and machines were detected through flow monitoring, and they detected through VP Instruments flow meter, and then they eradicated the leakages, and then they created a benchmark of each department so that whenever the benchmark crosses, they're able to work on that department and to eradicate the leakages of that particular department. So, which gave them the the opportunity to have a good grip on the leakages on all over their plant. Secondly, they were able to calculate the cost of air they were using on daily basis, and with these readings accumulated through VP Vision, they were also able to plan in a better way for their future expansion, because all the readings they had in actual form, not on hypothetical or which is rated data. It was all measured through instrumentation. So in Pakistan, we have a really good case study of Feroz 1888, who has benefited through this VP Vision system and have achieved the savings I've just mentioned. They already have achieved the ROI, which is 1 year, and approximate saving per year is 5.8 million. So, amongst our installations in Pakistan, we have a couple of more, but Feroz 1888 is the biggest and the most benefiting company who's achieving great savings through this system. So, this is the case study from Pakistan.
Great, great. Yes. Yeah, it's I would like to add a small note to this. The good thing about this project is that they could start with a yeah, with a relatively low investment. So you can start with a low investment, a basic monitoring system with some flow meters, and you can keep expanding towards the future. So you can actually let your savings invest in adding more sensors and getting more grip on your compressed air system. So that's a good way of increasing your monitoring system. So
True.
now I actually would like to show you a real live demo of the VP
Absolutely.
Vision system, so you will get a better idea of how it looks like. 1 second. I will just open it. So here you can see our VP Vision system, and maybe this, this will give you a little bit more information of what the capabilities are of the system.
Can you please zoom a little bit?
Yes. Is this better?
Yeah, this is.
All right. So our VP Vision system can be accessed from anywhere in the world, which makes it very easy for you and for us to do proper analysis. This is a project that we've done in Singapore. So as you can see, you can get a complete overview of how your system is running. You can see all of the power consumption. You can see the flow consumption. You can see the pressure. You can see the dew point temperature of all of your compressor rooms. So this makes it very easy for you to get a complete idea of how your system is running. Most factories they have no clue how their compressed air system is running, and this will give you a very good overview. I would like to show you briefly also some other features of this system. So as you can see, if you connect power meters to the system as well, you can see all of the current, voltage, power, and energy consumption of all the compressors. So here you can see we have a few compressors in room 2. You can measure the current, the voltage, the power, and the total energy. And you can also see the efficiency per room, or you can see the efficiency per compressor. It depends on what you want. You can customize this system completely to your liking. You can also see, for example, the cost of your compressed air system today. This can be also in Pakistan rupees. You can see the kilowatt hour consumption, and you can see the flow generation. And the nice thing is you can also see how are your compressors running, which is running the most, which is running the least. So it will give you an overview of maybe to justify your compressors, maybe let the other one run more or less, or it will give you a better idea of how to run your system. If you look at the flow meters, you can get a very easy view of all the data. All of the VPInstruments flow meters, they measure flow, pressure, temperature, and totalizer. So these names are also all customizable. So you can change this to factory A, factory B, factory C. You can see the consumption, the pressure, the temperature, and the total flow. Here you can see the dew point per area or per dryer, the total compressed air consumption, and the average consumption. And earlier we were talking about cost allocation. This is something that might look as the cost allocation analysis. You can see that my production A is using 78% of my total compressed air, and production B is using 14, and production C is only using 6.8. So it will give you a very good insight of where do I need to look first when I look for energy saving measures. Of course, I will look at the biggest chunk because this is the best way of saving money faster. So first you will start by looking at this area because it's the largest consumer. And how can I save energy here? And all these data is real time, but you can also see all the data historically. So for example, the last hour, the last day, the last week, the last month, or a custom period of time. But for example, if I want to see how are my compressors running today, I can just easily plot the graph, and I can also take a look at only 1 or 2 or 3 or 4. So it's up to you what you want to see and how you want to see it. There are all types of different types of visualizations. For example, for the flow meters, we can also plot graphs. So if you want to deep dive into the compressed air system and see how my flow is being distributed and what kind of problems are there, maybe you can easily see that here. So if there is any problem in the compressed air system, you can easily track it and justify it. You can also plot what's very, very nice to see. You can also plot different parameters. So here you can see we have in one graph, we have flow, we have pressure, we have dew point, and we have temperature. So if I want to see, for example, my flow versus my pressure, how is it running? It's very easy for me to see if my pressure is stable or do I have pressure problems. Or do I have dew point problems? This is the proper way of doing analysis for your compressed air system. Last but not least, I would also like to show you maybe one of the best features of this system, and that is the report. Reporting is maybe the most important because you can save energy on your compressed air system, but if you cannot report it to your management or to the financial department, then yeah, you have no leg to stand on because you need to have data to prove that you have saved energy on your compressed air system. So this report is actually doing that for you. This report can be sent to you daily, weekly, or monthly. So for example, you can see the total energy consumption, the total cost, the total air consumption. It will calculate the cost per meter cube for you, and you can also see the specific power, the efficiency of your compressed air system. So if all these values are okay, you know that your compressed air system is running properly and you don't need to take action. If you see that this is higher, for example, then you know, okay, I need to do something. You can also look, for example, at the flow meters. You can see my flow meters are giving 4% less and 13% less in area A and B. So I'm doing good. I'm saving energy here. But I see in area C, I have a plus 2% of flow. So that means that or I produced more, or there is a 2% increase of leakages. So you can see immediately where do I need to take measures. But total overall, you saved 15% air this week comparing to last week, or this day comparing to last day, or this month comparing to last month. Same goes for the power meters. You can see all the power consumption for all the power meters, and you can see the delta. So you can see, yeah, I have a minus 250% of kilowatt hour consumption. So I saved a lot of money here. You can get an overview of all the dew point sensors, the minimum, the maximum, and the average value. You can get a critical performance indicator overview. This is all customizable. And last but not least, you can get an overview of how your compressed air is running, how your compressors are running, how much kilowatt hour per compressor, and also how are my compressors running in terms of hours, standby time, loading time, running time, the total starts, and the cost. So yeah, that was our VP Vision system, which I wanted to show you. Of course, if you have any queries or other clarifications needed, we are here to answer your
Yeah.
questions.
So, like before we proceed to Dr. Arshid's remarks and his suggestions, there are a few questions that we are getting from our participants. Mustafa, Nathan, you, or Dr. Arshid, whosoever finds it suitable to answer. The first question basically is that what is the best choice of the flow meters for monitoring the flow rate of air compressors?
There are several types of flow meters that we offer. if you look at this picture, you can see that we have different flow meters for wet air and different flow meters for dry air. And we also have different flow meters for point of use. So for each individual project and for each individual needs, we can quote as per your needs. But for if you want to measure wet air, you need a different flow meter than if you want to measure dry air. But we can advise you per project.
All right. Okay, so the next question is, what type of compressor efficiency would you recommend for best representation of the actual condition of the compressor?
I think Mustafa would better be suited to answer this question.
Yes,
Yeah,
please, Mr.
I think you have to compare the output of your compressor with the rated flow. But there's a catch in this because the rated flow, which is mentioned on your compressor, is on ideal ambient conditions. So the correct way or the appropriate way to do is that you measure the flow with a flow meter and compare it with the rated output adjusted on the current ambient conditions. Let's say for instance, if today is 30 degrees and there's 50% or 60% humidity, so you have to adjust the reading of the rated output to the current ambient conditions. Then you should compare it with the reading which the flow meter is giving. So this is, I hope this answers the question.
All right.
Also,
So,
what's very important to know, I want to add one small note to Mustafa's answer, is that it's not only about uh, comparing it with the rated compressor, it's also seeing the difference over time. So if you buy a new compressor and you start measuring at that time, then that would be your benchmark. No matter what the value is, that's your benchmark. If you see over time that the efficiency is getting less, then you know that something is wrong with your compressor. So then you need to take action. So it's not only about the real number, it's also about the trend of that number over time.
all right. So, is there
Absolutely.
any case study that's related to the home appliance industry as well?
We have a few cases with a company called Samsung. Samsung, they make also home appliances like uh, yeah like washing machine, and we also have a case study on that. um, I don't know if I have it here. I can check. One second.
Yeah. So, meanwhile, I think we can move on to Dr. Arshad's comments on today's session. Dr. Arshad Ali is basically the CEO of AIIA, and it is his great efforts that we are seeing this amazing seminar. Dr. Arshad, welcome on board. It's lovely to have you here with us. Sir, we'll be waiting for your comments about this today's segment. And do you have any questions and non-comments regarding to today's discussion?
First of all, I would like to thank Nathan for such a lovely presentation. It was very insightful to learn about various ways and the technology which can be used in saving energy, which is one of the, I would say, biggest cost factor in Pakistan. I would also like to thank Nathan and VPInstruments for contributing VP Vision complete system for installation in Center of Excellence for Compressed Air, which has been established at National Textile University. So, Asif, can you please share the pictures of that center? So, this center is one of its kind, which has been established at the Textile University. And you see this center is a unique example of a living university industry partnership. Generally, people talk about it, but in this case, it has been materialized through the support from various industries like Ingersoll Rand, their division, which is Gardner Denver, VPInstruments for the VP Vision, which you don't see it right now over here, but will be is under installation at this point in time. And then Parker, which is the leader in piping as far as the compressed air industry is concerned, and Rasgar Group, which has helped in putting all this together. This facility will be available to the industry for looking at the live demo of how all these various components of compressed air system work. At the same time, we will be arranging training for the industry professionals as well as newcomers joining the industry in compressed air. At the same time, we are also introducing a course on compressed air to the undergraduate students at National Textile University. So, Nathan, thank you very much for all this contribution from VPInstrument and your side.
No problem. It's our pleasure to contribute to to learn young new students how to make proper use of compressed air. It's very important for the new generation, and also very important for the Pakistan market to get all the factories. It's their responsibility to focus on energy saving, to decrease the national footprint, but also the footprint of each individual factories. We see Pakistan as a strategic country for us. We would like to save more energy, and we are willing to continuously contribute to this goal.
Thank you. The first question which was asked was from Gatron Manager Pool Conference, where he asked about the compressor efficiency. So in understanding compressor efficiency on a continuous basis, I think the permanent monitoring is one of the key component to it. Then Hira Anwar asked for the compliance for the appliance industry application in monitoring the compressed air. So my question to Nathan would be, what is the smallest facility in compressed air which shall implement VP Vision system?
I think that the smallest system where it's already beneficial to install flow meters is likely to be from 90 kilowatt, 100 kilowatt and above. And then it's already interested to install a flow meter. Of course, the bigger your compressed air system is, the bigger your air consumption is, the more flow meters you need. So if you have a small compressed air system, you would also need less flow meters. Probably also one will give you a lot of benefits already. So it's already beneficial starting from I think 90 kilowatt and up.
Thank you. Even installing the flow meters alone as an independent will also give insight, but then you have to monitor it manually or understand.
Our flow meters actually, as a first start, our flow meters all measure flow pressure, temperature, and totalizer. So basically it's a 4-in-1 sensor, and it also has an integrated data logger. So if you have only one flow meter, you can install the one flow meter, you can start logging, and then after some time you just download the data, and then you can plot the graph of flow pressure and temperature over time, and then you can already get a lot of insight in how your compressed air system is running. How stable is your pressure? So one flow meter with a data logger will give you a lot of benefits already.
Thank you. We have Mudassar Hussain who want to ask a question. Mudassar, can you please ask your question?
Share it now. So he has shared the question.
Yes,
Yeah.
yes, sir. I have put my question. Actually, I belong to the plant second. Let's say I have installed this VPN system to my plant. which is away from the control room, let's say away 100 meters. So I want to ask that is this system have a capability for the wireless reporting system? Just like I want to report it and control it from the 100 meters away. So what is the range which is of the distance which can cover by the VPN system?
Actually, they're limitless because I can also log into your system locally. I just logged in. The demo that you showed was a system running in Singapore, so there is actually no uh, limitation of length where you can access the system, because the system can be connected to the Ethernet or to the internet using a router with a safe and secure cloud connection. So actually, it's not a problem. And even if you want to hardwire the system, so you don't want any interference, you can hardwire it already for more than 1 kilometer. So it's absolutely no problem to manage the distance.
Yeah, then we have question from Waleed Tariq. Is it feasible to implement air and electricity metering system as user of compressed air and electricity? I mean, we use both of them at our machines but don't generate them.
Yes, it's feasible because you can connect both the energy meters as the flow meters to our monitoring system. And actually, this is very beneficial for you. So, because you can see how much electricity is your machine using, how much compressed air is your machine using, and then you know exactly how much is that machine costing you, how much are the costs to run that machine. And if another machine is much more efficient, then you need maybe to run that machine, or you need to buy that machine, or your machine which is running less efficient needs to have maintenance. So definitely it's feasible to both combine air flow meters and electricity meters into our VP Vision system. This will only give you more information about your system.
Okay, thank you. We have Ahmad Kamal. He want to ask question. So can you please turn on the mic of Ahmad Kamal? Asif.
I have a question about the heat recovery systems. Since 80% of the energy is lost in the form of heat, and I have examples where 1 megawatt energy is consumed, and side by side they need hot water.
All right. Yeah. So, in terms of heat recovery, that's not our expertise. We are a manufacturer of flow meters and monitoring. So we focus on the compressed air system monitoring and not on a heat recovery system. So I'm unfortunately not the person that can answer your question.
I think, we can, we have noted your inquiry and we'll get back to you with this. There are some heat recovery systems with which you can recover some percentage of the heat which the compressor produces. And I think we'll be able to cater this inquiry of yours. We'll
In fact,
leave your email address in the chat. We'll give you the information on that.
Imtiaz,
I
may I
visited
have your
Hanover last year, and they were showing the heat recovery systems. Because if you need hot water 60-70 degrees, it is easily available from the compressors.
True, true. That's what I'm saying, and we'll give you the whole program and the equipment. But VP Instrument doesn't deal in that. They're
Okay,
only in
that's not your
instrumentation.
field. Okay. So my
Yeah.
second question is about the where you replace the blowers instead of compressed air. What type of steel industry it was?
It's this was. Let me check. I need to check this one.
Because here in Karachi, the international steels, they are using compressed air to remove oil emulsion from the sheet steels they are rolling.
All right.
So they use reduced pressure. They use pressure reducers from 7 bar to 4 bars. So that is a
Yes.
loss.
Yes.
And then I think they can use blowers in that case as well. Air knives, they work in that place.
Yeah, in this case, this was California Steel. This was a factory
What they were producing?
in the USA. I don't know exactly what they are producing, but they could change from compressed air to blower air because they had open blows. So uh, it was for cooling.
Okay.
Actually, it was for cooling. So they were cooling uh, with compressed air where they could easily use blower air. So there is where the change was made. So what I would suggest you is first of all measure after. So the best way is to measure before and after the pressure reduction, right? So you know exactly how much air with what pressure is going in and how much air with what pressure is going out. So you can do proper analysis, and then you can see if there is a blower manufacturer who can cater those needs, those exact pressure and flow consumption um, with a more efficient way, in a more efficient way. But the first thing you should start with is first measure it to know what the consumption is.
Okay. I have another question. Can you compare different type of
Mr.
compressors
Ahmed,
like
can
screw
we
type?
have the opportunity to other people also
One
have
more
the
question,
question?
just one more question, just one
Okay.
more short one.
Okay.
Can you compare different type of compressors like screw compressor and centrifugal compressors, and how much their specific consumption compare?
Yes, you can do that if you install sensors. So if you have two types of different compressors, you install power meters on both of them, you install flow meters on both of them, and then you see what is the kilowatt per cube per minute of both of them, and then you can see which is more efficient.
And yeah.
This can only be done after measuring.
We have very important question from Mohammad Rizwan. Question is how to select the supply pipeline of compressed air along the compressor, and what should be the sequence of dryer, filtration system, and storage tank. This I would share that this is very important question, and common mistakes are made at the initial stages, which results in quite a lot of loss. At Center of Excellence in Compressed Air, established at Textile University, we have followed the international best practices in installation of the whole system. I will ask Nathan to please comment on this.
So actually, this is a question I think better answered by you or Mustafa. The only thing that I can say is that this depends. All these things depends on your consumption and on the ambient conditions.
I would like to add to this, Rizwan Saab. Look, the supply pipeline, if you're talking about the sizing of the pipeline, it depends on the amount of volume which is going to be in that pipe. So there are calculators available online, and it's a whole study and a complete calculation with which we see the velocity of air, the volume of air which is going to be passing through it, and the pressure. So on the basis of that, we design the diameter of it. As far as your other part of the question is that the sequence of dryer, filtration system, and storage tanks. This is also a best practices standard, and as I am representing Air Audit Private Limited, which is ISO certified on compressed air systems. So there's an ISO standard which says, if I summarize it, it roughly says that you should have a dry tank, then the filtration, then dryer, then the after filters, and then the dry tank. Sorry, the wet tank, filtration, dryer, again filtration, and then the dry tank. So this is the roughly sequence of which you should install all this equipment. But this is another inquiry which maybe if you can email, we will cater it in a better way.
Yeah, an important note I would like to make on this question is that don't forget to have a dry tank, because we see in a lot of countries where there are humid conditions that they always put a wet air tank, so a wet tank, but then they just have the dryer, and after the dryer it goes immediately to the factory. Um, the problem with this is if you have a increase of flow, um, the dryers maybe cannot handle the amount of air that you need to dry, so your dew point will go up. So I will always suggest to have a dry tank to um, to make sure that your dew point is always maintained. And also a dry tank will also result in less loading unloading of your compressors, because you have capacity left to cater your peak needs. So the more storage you have, the less your compressors will start loading, unloading, which will in the end save energy, of course.
Okay, thank you very much. Can we have any question from Noman Sajjad or Iqbal Lakhani or Irfan Yusuf from NEPRA? Anybody interested in asking any question, please?
Or maybe giving
If you
feedback.
can raise your hand, or we can turn on your mic. Okay, if there are no questions, then from Mudassar Hussain. Okay, we got your email. So thank you very much, everybody. I hope this session would be useful for you. If you have any queries, you are most welcome to contact us. We shall try our level best in order to address your questions and your concern. We will be extremely happy to be of any support in any way we can. Thank you very much, and we shall look. We have hand raised by Sayyida Hira Anwar. So can you please turn the mic on for Hira Anwar? Asif.
Yes, sir. I am turning her mic.
Hira Anwar.
If you can send us the question in chat.
Asif, why it is taking so long?
Yeah, sir. She has not allowed to turn on her mic, so we can take her question through chat or something else.
She has raised hand to ask for a question.
Sure. Yeah, but
Can
her
you
mic
turn
is not.
your
She's not
mic?
allowing me to.
Here, if you're listening to us, can you please turn on your mic?
So I think there might be some technical problem. So with that, I would hand over to our host for the closing of this particular session. Over to you, please.
Thank you, Dr. Rashid. Thank you, Neetan, and thank you, Mustafa, for an excellent session on energy saving and consumption regarding compressed air. I think this was a very valuable and knowledgeable section for us to understand. In the previous webinar that we arranged, AII arranged a seminar around saving business opportunities and how to survive during the pandemic for small businesses and out this. And I hope that we continue to bring new and more informative webinars and seminars for you all. And if you have any sort of questions or suggestions regarding training in future as well, you can send us emails, and you can just leave the comment in the comment chat as well. And you can also like us on our Facebook, Instagram, and LinkedIn pages, so that we know what to contribute in future. Also, the recording of this whole session is also available in the chat box, and it will be shared on all our digital platforms as well. So, signing off from here, thank you, Nathan. Thank you, Dr. Arshad. Thank you,
Thank
Mustafa, and
you.
all the
No problem.
participants who have been an excellent contributor towards today's discussion. So, take care and Allah Hafiz.
Thank you.
Bye bye.